66. Let's read the question. When 50 ml of 0.1 molar ammonium hydroxide is mixed with 25 ml of 0.1 molar HCl, then pH of the resulting mixture is, we are given with the value of pKb, which is 4.74. Student, first of all, I'm writing the reaction that occurs between ammonium hydroxide and hydrochloric acid. So ammonium hydroxide is NH4OH plus HCl, which gives NH4Cl plus water. Here at T is equals to 0, 0.1 molar NH4OH is 50 ml is taken. So 0.1 into 50, that means millimoles of NH4OH is 5. So 5 millimoles here I'm writing. And the millimoles of HCl is equals to 0.1 into 25 ml, which is 2.5 millimoles. Initially, there is no product. So at equilibrium, let's take 2.5 moles of HCl reacts with 2.5 moles of ammonium hydroxide. So 2.5 millimoles of ammonium hydroxide are left and 2.5 millimoles of ammonium chloride are formed. So student, it is very clear that this is an example of basic buffer. So for that, we'll be using the formula to calculate pOH, which is equals to pKb plus log the concentration of salt upon the concentration of base. Let's put the values. pKb is equals to 4.74 plus log the concentration of salt, that is ammonium chloride, will be 2.5 upon total volume, that will be 75 ml, and the concentration of ammonium hydroxide will be 2.5 upon the total volume, that is 75 ml. That means the concentration of ammonium chloride, that is the concentration of salt, is equals to the concentration of base, which is ammonium hydroxide. So it will be log 1, which is equals to 0. That means POH is equals to PKB, which is equals to 4.74. So the correct answer is option number 1. Here I'm writing answer is option number 1. Moving to next question, which is 67. Let's read it. If the solubility of silver chromate in water is S mole per liter at 298 Kelvin, then its solubility product KSP will be. Student, I'm writing the reaction of decomposition of silver chromate into its ions. Ag2CrO4 gives 2Ag plus aqueous plus CrO4 2 minus aqueous. So the solubility of silver chromate given here is S mole per liter. That means the concentration of Ag plus ion in the solution will be 2S and the concentration of chromate ion in the solution will be S. So let's calculate KSP, which is equals to concentration of Ag plus raised to the power 2 and the concentration of CrO4 2 minus, which is equals to 2S square S, which is equals to 4s cube. That means the correct answer is option number 2. Moving to next question, which is 68. The molar solubility of aluminium iodide in 0.1 molar solution of Ki will be. We are also given with the KSP of aluminium iodide, which is 1 into 10 to the power minus 12. So student, first of all, I'm writing the reaction of aluminium iodide. Ali3 gives aluminium 3 plus plus 3I minus. So let's assume the molar solubility of aluminium iodide in the solution be S mole per liter. So aluminium ion will be S mole per liter. So the concentration of aluminium ion will be S mole per liter and the concentration of iodide ion will be 3S plus 0.1. 0.1 is from the potassium iodide because potassium iodide also gives 0.1 mole of iodide ion. Now students, let's calculate KSP. KSP is equals to concentration of aluminium ion multiplied by concentration of iodide ion raised to the power 3, which is equals to S 3S plus 0.1 raised to the power 3. Student, here I'm writing the 3S plus 0.1 is approximately equals to 0.1. That means the value of KSP becomes S multiplied by 0.1 into 3, which is equals to 0.001. Student, we are also given with the value of KSP. Here I'm writing 1 into 10 raised to the power minus 12 So S is equals to 1 into 10 raised to the power minus 12 upon 10 raised to the power minus 3, which is equals to 1 into 10 raised to the power minus 9 molar. That means the correct answer is option number 2. Here I'm writing answer is option number 2. Moving to next question, which is 69. Let's read it. What amount of Ag2CO3, that is silver carbonate, is dissolved in 250 ml of water? Student, here first of all I'm writing the reaction of dissociation of Ag2CO3. So Ag2CO3 to give 2Ag plus CO3 2 minus. So student, let's assume the solubility of silver carbonate in the aqueous solution is S mole per liter. So this will be 2S, this will be S. So Ksp is equals to 2S square into S, that is 4S cube. And the value of Ksp is given, that is 8 into 10 to the power minus 12. So 8 into 10 raised to the power minus 12. So the value of S will be 1.26 into 10 raised to the power minus 4 molar. Now student, we are given with 250 ml of water, and also we have to calculate the amount of silver carbonate that is dissolved. So student, the amount, that is the mass of silver carbonate dissolved in 250 ml of water will be 1.26 into 10 raised to the power minus 4 multiplied by the molar mass of silver carbonate, which is equals to 108, that is the mass of silver, plus 12, that is the mass of carbon, plus 3 into mass of oxygen, that is 16, which is equals to 276. That means 1.26 multiplied by 10 raised to the power minus 4 multiplied by 276 multiplied by 250, because the water is 250 ml, divided by 1000, which is equals to 8.69 into 10 raised to the power minus 3 gram. That means the correct answer is option number 1. Moving to next question, which is 70. Let's read the question. The solubility of aluminium hydroxide in a solution of pH 8 is, we are given with the Ksp of aluminium hydroxide, which is 8.5 into 10 to the power minus 23. Student, here the pH is 8. That means POH is equals to pH 14 minus pH, which is equals to 6. That means the OH ion concentration is equals to 10 raised to the power minus 6 molar. So aluminium hydroxide is equals to aluminium 3 plus plus 3OH minus. Let's assume the solubility of aluminium hydroxide as S mole per liter. So this is S and this is 3S plus 10 to the power minus 6, from, because it's already given that the concentration of OH ion is 10 to the power minus 6. So Ksp is equals to concentration of aluminium 3 plus and concentration of hydroxide raised to the power 3. This is S and this is 10 raised to the power minus 6, because 3S plus 10 to the power minus approximately equals to 10 raised to the power minus 6 cube of this, which is equals to Ksp, and the value of Ksp is 8.5 into 10 raised to the power minus 23. So the value of solubility is equals to 8.5 into 10 raised to the power minus 23 upon 10 raised to the power minus 18, which is equals to 8.5 into 10 raised to the power minus 5 molar. That means the correct answer is option number 2. Here I'm writing answer is option number 2. Moving to next question.